Hello testers, and welcome to another STP community webinar. My name is James, I'm the event coordinator here at STP. We're excited to have everyone on the webinar today. Today, Jeff Singh will be joining us from Redwood City, California, and he'll be talking about quality leadership, testing, and governance tactics that make or break your progressive delivery system. A few things to cover before we get started today. A reminder, we have an upcoming webinar on February 24th from Steve Hilton at Mock Nation. The presentation will cover not only why enterprises are using performance testing for their Internet of Things, but what are the top performance tests they are conducting. Visit SoftwareTestPro.com to read more about this and register for this webinar. You can also view all the upcoming webinars from STP that are scheduled so far in 2021. Looking to practice your speaking and presentation skills or have an idea for a webinar topic? STP is looking for both new and veteran speakers and is currently filling the 2021 community webinar schedule. So submit your proposal today at SoftwareTestPro.com. If you're on social media and talking about today's webinar, be sure to tag us at SoftwareTestPro and use the hashtag STPWebinar. So let's get started with Jeff. Please welcome Jeff today. We're excited to have you. Let me give you control.
Perfect. Thank you, James. Let's share my screen. Good morning. I'm on the West Coast, so for all of you that are on the East Coast, good afternoon. My name is Jeff. I am a senior QA manager currently at Iterable. Iterable is a cross-channel marketing platform with customers like DoorDash, Madison Reed, Zillow, and ASICS. So basically not just an e-commerce platform, but Iterable is a company that really wants or needs to control their customers' experience and understands and measures every interaction across their entire customer journey. So I've been in QA for 15 years in a variety of different industries, everything from web security to fraud, medical devices, marketing tech, and then these companies are everything from 15 people to publicly traded couple hundred. So before Iterable, I was at Optimizely, and Optimizely sold a product which was experimentation and progressive delivery. While Optimizely, I was sort of our progressive delivery champion. And the reason why this happened wasn't because I was hired to be, this champion. It was because we just didn't do it very well in the beginning. And when we did use the progressive delivery, it caused so many issues that, it eventually bubbled up to quality and it became a quality issue. So that's kind of why I'm here today, right? Today, I'm here to talk to you a bit about some of the lessons I've learned, some of the things that we've adopted that worked really well, and some of the things that I wish we adopted that could have been better. So let's dive in. On today's agenda, we're going to talk about quality leadership, testing, governance tactics that make or break your progressive delivery system. And yes, that is super mouthful. I apologize, but there is a lot to unpack here. The basic two things we're going to talk about today is what is progressive delivery, who's using it, why are people using it, why is it so powerful, and why are engineering teams more and more likely to adopt this? And if your engineering team has adopted progressive delivery as a quality leader, right, how should you be setting up testing against this? And more importantly, how should you be thinking about the orchestration or governance of it? So we'll be covering those two topics today. So let's get into this. What is progressive delivery? Well, progressive delivery basically was this term coined by James Monk from RedMonk, right? Basically, it's a modern software development, paradigm where you are kind of deploying into production behind a feature flag, and you're able to test at scale using this feature flag. And I like to use progressive delivery and feature flags interchangeably, but for this talk's sake, let's imagine progressive delivery is feature flags. So when we say progressive delivery feature flags, right? When I say modern engineering, who's currently using this? Can we see this in real life? And if you look at things like companies like Netflix, right? Netflix is, one of the most, they use feature flags for almost every release. When I have a few friends that are working in QA, when I talk to some of their engineers there, every single feature is gated, right? They don't believe in ever launching. They are going to slowly roll out a feature, to a customer base, slowly roll out a feature to, different countries. And they really want to make sure that what they release works and that it's well adopted. If you look at companies like Google, right, they even tell you, hey, here's our feature flag. If you want to try using this feature, go ahead and enable it. right? So this gives them the data to see what people like. Amazon, is looking at how they can help their customers, implement features like stage rollouts or stage releases. And even Facebook, right? You can see publicly they're talking about, hey, we're testing dark mode, right? They're using feature flags here to give an experience to certain customers and testing that experience to make sure that it works right and that the customers are loving it. So when I talk progressive delivery feature flags, what is progressive delivery versus continuous delivery, right? Well, continuous delivery is a set of practices that ensures your code is always in a deployable state, right? We kind of do this by increasing the frequency at which code is committed, built, tested, and deployed. And this is good because for QA, right, it reduces the risk because we have smaller changes. Changes are more isolated, and we allow to test more, and we're allowed to test smaller, right? So this kind of really helps us release, confidently. Progressive delivery, on the other hand, takes us even to more so to the right side of the delivery model, right? Progressive delivery, is a technique delivering changes first to small, low risk audiences. And then as you're comfortable and that hasn't blown up, you can slowly expand to larger and riskier audiences, validating the results as you go, right? We basically can ship code behind a feature flag into production, and then we can target, either yourself, a beta, or certain audiences, and you can slowly roll out that feature. And if there's a problem, you can roll it back with a flip of switch, right? And this gives you that data to say, yes, this feature is working, people are happy, we have a good, launch. And this kind of brings me back to this concept of data-driven software development, right? As QA engineers, we always ask the question, did I build the product right? All our testing, all our automation, explore testing, test cases, this is all orchestrated to answer this question. But what we cannot do, and it's very hard for us, is to answer this question, did I build the right product, right? And that is also huge benefits of feature flags, because you can see feature flags allow you to do things like, limit the blast radius, test your feature to prove business impact in production, and remove that in case it doesn't work right? So let's give you a real world example of what I mean. What happens when a company does not make good data-driven decisions? A few years back, Snapchat released a redesign of their features, right? Guarantee you their engineering team tested this. These features work, right? They're very confident that they're going to get adoption. They rolled it out. Well, they launched it. What happened? People didn't like it, right? A lot of influencers said this is the worst thing ever. They lost millions of users for good. And, how much money did that cost them, right? That is pretty, detrimental. So what is feature flags, right? Feature flags, basically, in simple layman term, is, a toggle, right? If the toggle is on, we expose your code to, your customers. If the toggle is off, basically it's gone. And obviously, this is the very, very simple explanation of it, right? More, robust implementations of this have things like, can I deploy to a certain percentage? Can I deploy to a certain user? Do I have certain feature variables inside my flag that can, control certain things? But the gist is basically, hey, it's a simple toggle that I can dynamically change the experience that my consumers or customers are seeing in real life data. So let's talk examples. Here is what I call a feature rollout, right? The most common case of feature flags is I'm going to roll out a feature to production. In this example, we have our app and we have something called mobile app header, right? And the flag is disabled. When we're ready to roll out, the code's all there, we feel confident, we can just simply flip the switch and our customers will start seeing our new feature in production, right? If we find out that this feature doesn't work, when customers come in, it's the wrong sizing, it looks weird, we can always disable our flag and it instantly just goes away. So that gives us the power to control our blast radius. So let's look at feature flags and the benefits inside our software development lifecycle. During our build and test stage, right, the key thing is features don't need to be completed to get merged, right? And this is powerful because we don't waste time untangling messy merge conflicts. This is kind of the concept of trunk-based development, right? I've seen developers ship code into production behind a feature flag, and then as it gets ready and they can start testing, they can slowly, they can actually bucket themselves into the feature flag into production and test there. And when they're ready, they can release out. And what this gives you is allows you to ship faster by decoupling deploys from release to shorten the dev cycle, right? What this means is, I've been in many different companies, and I know some companies here don't have the concept of deployment trains, right? Some companies can deploy whenever you want, but other engineering organizations sometimes has cadences, right? Like, hey, we have, bi-weekly cadence, weekly cadence, monthly cadence. And we've all seen problems where like engineers are rushing to hit that cadence, or else they're not going to deploy till next week. Well, with feature flags, we don't have that problem because your code's already in production. And when you want to deploy, you're not waiting for cadence. You can just flip that switch. Which brings me to release, right? Iterable, we use our feature flags here, and developers don't actually release, right? We do have our cadences which we ship code, but we give the switch to our AEs or CS that are supporting our customers, and they are allowed to turn on the features for their customers first, right? So they can kind of test it out themselves. We're basically empowering them to control this. And also, most importantly, for QA, and this is by far why I am a huge proponent of feature flags, is it allows you to quickly roll back production incidents, right? So an example is, developer puts a feature behind a feature flag, rolls out, flips it on, right? And then something goes wrong, they can turn off the flag, it's gone, right? At Optimizely, our mean time remediation was about 15 minutes. From the moment we detected something went wrong because of feature flag, we were able to remove it from production within 15 minutes. And that's high. I think on average, it's about 8 to 9 minutes. Before feature flags, right, you would need to either A, roll back the build, so some implementation, your SRE has to come in and help you, or B, you have to fix backwards or fix forwards, which takes time to build that build, right? And depending on how fast your build system is, that's longer than 15 minutes. So your, MTTR is going to just be amazingly good. So that kind of gives me my overview of what is a progressive delivery system or feature flags, why it's so powerful, and why so many engineering organizations, so many companies are adopting this as their delivery strategy. Now let's move on to testing and governance tactics, right? What does it mean when I say governance and testing? Well, if we think of deployment with feature flags as launching a rocket, then my governance is my mission control. And mission control, as we know, is the ability to determine, everything from what fuel we're using, when we launch, how we launch, who's in control, communications, strategy to get the rocket up and out and maybe even back. Testing is damage control, right? It's make sure that when we flip the switch, it doesn't just explode, and if it does explode, like what's my expectation? Together with governance and testing, we can successfully launch our features. So what could go wrong, right? Why do we need testing and why do we need governance tactics? These are actual stories that I've seen. And if you look up, like, every company that uses feature flags, I always see, an architect or someone says, boo, feature flags, boo, right? If you Google, why feature flags are bad, number one, is feature flags are one of the worst kinds of technical debt. And yes, it's true. Feature flags are one of the worst kinds of technical debt. I think as a QA lead, this is what keeps me up at night when I join organizations that use feature flags that don't have a good idea of how they're testing it, and worse, how they're managing it or governance, right? What does this mean? So one, what does this flag do? So many times I've seen companies where they build feature flags, but they're not managing it, and they name it all kinds of weird nomenclature, and then they leave, right? There's nothing worse than joining a company and you're like, hey, what does this feature flag do? Well, the guy who wrote it's gone. He left. No one knows what it does. So we're just gonna have to label it never turn off. And that's it. For the rest of your life, there's a feature flag in your code base that you have no idea what happens. Who turned off my flag? this one's even worse, right? New engineer comes in, they name their flag something very similar, and they're learning the product, and at 9 in the morning, they're like, okay, let me turn off my feature flag, but they turn off the wrong feature flag, and suddenly you have a production incident, right? This has happened before on my watch. Who touched my flag? And this one isn't necessarily, oh, an engineer came in, modified my flag. This is almost more insidious, right? It's like, I have a flag, I left it in, forgot about it, it's in my code, and people are building on top of my code, and then they put feature flags above me or below me, and they're toggling them on or off. Suddenly, my feature flag isn't doing what I think it's doing anymore, right? People didn't realize I'm downstream or upstream, and it's affecting, how my flag is working, and that can cause catastrophic problems. So if these don't scare you, let me give you a real horror story. And thank God this has never happened to my company, but this is like, the QA boogeyman story, right? Knights Capital. So Knights Capital was a very, very large trader in US equities. Back in the days, they had a market share of 17.3% on the New York Stock Exchange and 16.9% on the NASDAQ. Their specialty was what we call high frequency trading algorithm. So developers were like, hey, it'd be a good idea, let's reuse a feature flag. So they had a feature flag, no one's using it, they're like, hey, let's just recode it. So they recoded it, they add some code, deployed it across all their servers. One server, that feature flag was still in use. So when they turned that flag on, it came back to life. So one server out of all of theirs started making as many trades as fast as possible without limit. They discovered this pretty quickly, and within 45 minutes, they turned it off and they rolled it back. But within that 45 minutes, what happened? They lost $500 million, and this took down Knights Capital, right? That's $500 million like loss. So how do we make sure that we're not making these mistakes? When I talk feature flag governance, I look at 4 big kind of categories that I think we need to be aware of. The first one is what I call flag information. And this means your feature flag, at any point, you should be able to look at it, or someone should be able to look at it, some engineer or who's using these feature flags, and they should be able to tell, what does this flag do when it's on or off, right? It has to be readily available. What environment is this deployed in? And this is important, right? Because if you have a staging environment and a production environment, you need to know, your engineers need to know that this flag is on in staging and on in production, or if it's on in staging and off in production, that will affect how you test your flag, that will affect the behavior of your flag in production or features in production. Visibility, right? Think of feature flags as almost a deployment mechanism. You would not deploy something into production and not let anyone know, right? Same thing, when you turn a feature flag on or you turn it back off, what is the communication strategy you should be giving to your engineering organization? And who is monitoring the metrics? Who is monitoring the behavior of your feature flags, right? Where is this documented? How do I know, if my feature flag is successful or not? The second category is what I call access level. And for access level, it's who's allowed to make changes to this feature flag. And it's really important. One of the examples I can give is at Iterable, like I said, our AEs turn on feature flags to give customers certain experiences, right? And that's all well, but we also have things like a rate limiting feature flag that controls rate limiting. We don't want to mix these 2 feature flags. We don't want an AE to accidentally turn off rate limiting or make changes to it, and suddenly our servers go crazy, right? Like we don't. At the same time, I don't want my intern to come in here and turn off a feature for a customer. Also, how do we track this, right? What's your change history? How do you know when someone makes a change, right? This is really important because, if you don't know why your system's behaving a certain way and how it got there. Next category is risk level, right? Do you understand how dangerous it is to roll this out, right? If you're launching your feature flag, what's the worst thing that can happen? And then what happens if something does bad happen to this flag, right? Can I roll it back? Can I not roll it back? Do I have to fix forward, right? If it's a backend feature flag change where we're dynamically changing, the schema, in that case, we may not be able to just roll it back. The front, the data is already there, right? So what's the strategy there? And lastly, I think one of the most important things is exit strategy. Exit strategy is important because this is kind of what I brought up, technical debt. right? When is this feature flag no longer useful? And when this feature flag is no longer useful, who's going to remove it, right? You should, because if we're never going to touch part of your code, why is it in your, why is it in your product, right? You should remove unused code. This is dangerous. It's a liability happening. So that's my basic, 4 categories of feature flag governance. Let's dive into testing. Oh, sorry. Let's actually give you some real examples. I like to use Jira as an example because I'm almost positive 99% of us all here have Jira set up. I've seen teams use Trello. I've seen teams use Confluence. I've seen teams use Google Sheets or Excel. If you have a vendor of choice that sells you feature flag software, they probably have a way for you to orchestrate this. But for today, my examples will be in Jira. So preface, when I set up Jira as a feature flag governance tool, I like to create a feature flag type in Jira. And this feature flag type represents a one-to-one relationship between the actual feature flag. So if my team is building a feature flag for Epic to launch their feature, this feature flag type will be added into the Epic. And if I have tasks and PRs, links to Git that built this flag, they'll be located inside this Jira ticket. So I can easily see everything that's being done. Now let's talk flag info, right? I mentioned before, we want to see feature on, feature off, right? And who actually owns this feature flag. Pretty simple, right? If I was to, in Git, if I say, okay, I want to find out which feature flag this is, I can see the name of the feature flag up top. I can go and search for it, and it's here. It tells me in plain English what happens when it's on, what happens when it's off, and who actually wrote this flag. So there isn't this discrepancy of, oh man, someone left. We have no idea, who owned this or who made changes last, right? This is the owner. For governance, right, really important, can I roll this back? And what happens if this flag fails, right? What I'm looking for here is the danger if we turn this off, and simple yes or no, can I turn this flag off? And I think this is very valuable. I brought this story up, an engineer on call didn't write the feature flag, finds out the feature flag is causing the outage, right? They should be able to go to this, Jira, quickly see the risk, and it should tell them, go ahead and turn it off, right? Then they can just switch it off, go back to sleep at 2 in the morning, and everything's good. Exit strategy. This one, generally, I like to say is, usually product and engineering come to the conclusion of what the exit strategy is, when the expiration date should be, and then most importantly, who's in charge of removing this. It could be the person who wrote the flag, should be the one report it, should be the one removing it, or it could also be, engineering on call, removes it. Could be separate, feature flag removal day. It could be a hack week event, kill the feature flag. Depends on your organization, right? But what I like is, to be able to say who should be assigned to do this, so I know that someone's looking at it, so it's not technical debt. And also, when I use Jira, we create custom stages, right? So ready to be removed. I know this flag is ready to be removed. I can track that. All right, let's talk testing strategy. So here's my friendly test pyramid. So as a quality engineering leader, what should you be looking for in terms of testing your feature flags? So let's start in the bottom, right? Unit test. So unit test, your developer should be writing these with the mentality that you really didn't have any feature flags in your code base, right? Every code path should have its own set of independent unit tests, right? They shouldn't be like, oh, we're not going to cover this path, so I don't have to worry about this logic anymore. You should just, everything should be tested. The integration level is a little more interesting. You want to have orchestration to mock or stub your future states, right? So you want to make sure those code paths are tested correctly. And that way, you can be confident that, the integration level when turned on is actually doing what you think you're doing. Now, UI tests and above, generally the SaaS companies that I work for, we don't really have a lot of QA engineers. So integration and unit generally is a partnership between QA and dev, but QA tends to own the end-to-end testing in the UI section and run a lot of the manual tests. So for end-to-end test, right, obviously if you have, one path on or off, it's pretty easy. You can write both feature on, feature off. But if you have multiple variations, it gets more complex, right? You really need to focus only on the important variations, right? Your test runner needs to be able to go that route. Finally, manual testing. Manual testing, obviously, it's the most expensive, and you should be testing only the critical variations. But the thing that as a QA leader you should be thinking about is if you're going to ask, say you have manual testers or you're manual testing, you need to provide your testers the ability to actually bucket themselves into the feature variations, and you need to give them the tools to allow them to see, logging. Like, hey, am I in the right variation? Am I in the right version? And then they can say, hey, is this the right behavior? Example of this is Peloton. Peloton actually has some, QA testers, but their product isn't per se on a, desktop, right? Their product is on like an iPad, let's say, right? So the Peloton delivers to their QA team you shake it and it comes up with a screen and it lets them do some modifications, right? So in this case, it's really important that you give this tool. I've seen a lot of companies where they have manual testers and they aren't able to test feature flags because they don't know how to bucket their testers into the variation. And that's really, really dangerous. So general end-to-end automation test strategy. Like I said before, there really isn't much to it, right? You want to test feature on and feature off, right? But you'd be surprised at some automation teams where they don't really realize that there's a feature flag on and off. And when that happens, you have a test runner plus indeterminism. And what do you get? You get flaky tests, right? All of a sudden you're like, why is my test failing? What's going on? Where did this come from? Well, someone turned on a feature flag and you didn't know about it. And that's not good, right? So to set yourself up for success, generally, the most important thing I would say for end-to-end automation is your test runner needs to know if a feature flag is on or off. And in fact, your test runner should be orchestrating your feature test on and off. And to do this, you can use a special test user. So for example, you can pass in, your test runner, ID into your app, and your app feature flag knows that if it sees this ID, it should be on or should be off. You can have a test cookie, or what we do is we have a test query parameter, right? So query parameter, feature flag is on, expect this. Feature flag is off, expect that. And it's pretty simple, right? It looks just like this, right? Here is our Cypress test that we use as an example. And it's simply, and this is actually, we're using an example here called the Astro Boy, but our actual implementation doesn't look much more complicated. It really is just, side.visit, and then we pass in our query parameter for on, and then we do all our validation for the enabled features that we're expecting, and then we do a regression test of the off, right? And we just pass in the off, and we're able to bucket in and out. So yeah, that's it. I've now covered general governance topics and general automation test strategy for your feature flags. That's it, right? Pretty simple, right? Well, herein lies, I think, the more advanced topics and things that some companies do really well, but they completely miss this next section. What if I told you that there are more than one type of feature flags and you need to test and govern them all differently? This is huge, right? Because I would say feature flags, there's two types. There's a short-term flag and your long-term flags, and they do completely different things. So we talked about feature rollouts for the last like 20 minutes, right? It's, hey, I have a feature, I want to roll it out to my customers, and when I'm done, I should remove it. It's done, right? I don't want the old code. There's also a kind of feature flag called experimentation. And this is how you perform your A, B, and test against your deployed features, right? And what does this mean? So say you have an app and your design team is thinking, hey, we want a header, say, we love our users. And the other one used to say, hi, welcome. And you're wondering, if I spend the time to build, we love our users, will it actually generate more conversions? Will it actually get people to check out more? Will it drive NPS up? We can measure this, right? So with feature flags, we can say, let's set traffic 50% to, this version, and we can send 50% to this version, and then we can measure our conversions. And the winner will deploy out, will keep forever. The losers we can get rid of, right? And this drives our data-driven engineering because now we know for a fact that one's better than the other. So both of these are short-term, right? Once they're done, you should be removing the code that we no longer are using. What about our long-term flags, right? These are feature flags that we are using that we may not remove ever, right? What are these? Well, the first one is permission. Permission flags change your product experience that certain users receive, right? So what this means is, for example, let's say you have a premium tier user, right? If this user pays you more money, they get certain more features. You can bucket this behind a feature flag. So when they come in, if a normal user comes in, they don't get the premium view experience. But if a premium user comes in, the feature flag sees it and they say, okay, they pass in the user tier. Let's give them this premium, experience. Companies that I worked for use this to bucket subscription models. They bucket, tier A, tier B. Oftentimes our ML data, usually it's an upgraded tier. To get that feature set, they have to, we hide them behind feature flags. So this is, a way to kind of do permissions. Operation. So operation feature flags are almost our DevOps feature flags. And I would, say almost every company I've worked for actually has some version of this already implemented, right? And they may have implemented slightly different than your feature rollouts or experimentation. But operation feature flags basically control operational aspects of your system, right? They allow you to dynamically change something of your feature flag through either a feature configuration or a feature variable, right? Let's talk an example. Here, right, we're using checkout flow and the checkout code version is 3, right? I dynamically can change the variable checkout for through my feature flag without doing a code deploy. And what that means is next time my customer comes in, they get a different version. This example is kind of wonky. I can give you a better one, right? Optimizely use operational feature flags to change their fav icon, right? Why? The feature variable they use is the source where the image location is. Now, what is the power of this, right? The power of this is I can change my value without doing a deploy. I can just put it into the configuration file. Once it gets updated, it gets there, right? I don't have to, pull my config file. I don't have to make that change and then push it up, merge it, build it, and then wait for that, right? We see things like we can control level of logging, right? No logging, full logging, middle logging dynamically. You don't have to go in and change the config file. We can do things like, how many machines we want to spin up, right? We don't have to wait for that dynamic change. We can just push it directly through a feature flag. So it's a very DevOpsy operational flag. My final flag is what I call a circuit breaker. And this is simple on-off features, right? Circuit flag on, features on, flag off, features off. My example here is we have a search ranking algorithm and it's bucketed by, it's, tied into a feature flag that is circuit breaker. When there's high traffic, that search algorithm might be too expensive, causing slow page loads, we can just turn it off. So other things I've seen with circuit breakers is like, for example, New Relic tends to charge you more if you go over a certain limit. You can always put a circuit breaker there. And if you're getting close to that month end, starting to charge you a bit more, you can turn it off until next month, right? So all of these feature flags are the same, right? They all kind of work the same way. They're implemented the same way. They're a feature flag in production. They allow you to make dynamic changes. But the way you think of how you govern these and the way you test them are completely different, right? We have, a rocket, a helicopter, and balloons. They all fly up, but they all go different speeds and they do different things. And then our airplane may not even go up, right? It goes left to right. So let's dive into this. For feature flag governance, for my experimentation flag, the difference here is for flag info, it's really hypothesis driven, right? We want to know what my experimentation is. What am I looking to get out of it? How do I know if it's successful or not? That's what I want to see when I click into this experiment. For access level, it's product and engineering, right? I mean, generally those are the people that are running your experiments, they have access to it. And the risk level is low. We're running an experiment, both, let's say A, B, both your A and B should be ephemeral, right? At any point you could say both of these suck, none of these got to, the conversion that I wanted, So let's go back to the drawing board. And my exit strategy should be the moment my experiment ends, get rid of it. You're done, right? Why keep, an experiment that's over live in your code base? For permissions, the flag info should really be your business tier provisioning info, right? If your company uses, permission flags to gate subscription models for your customers or experience for your customers, you should have this information when I click this flag. I should know which customer types are in there, how much ARR, what features are governed, what the outage principles are if something goes wrong, right? Because the risk level is high here, right? If a customer is paying you a lot of money for a feature and suddenly that feature is gone, you have a problem, right? So your access level really should be restrictive. You do not want someone to accidentally go in there, turn off your permission flags to remove it, right? It really should be restricted to the AE or however your GTM org has it, that they should be the only ones able to turn on or off these flags. And the risk level here is high, like I said. Generally speaking, I don't ever see companies remove their permission flags unless, they decide that, hey, we want to give this feature to everybody. So take it out. Or this feature we're no longer selling this feature. We're no longer even going to bucket it. Let's just remove everything. Then remove it. Our operational run feature flags, like I said, these are more DevOpsy. So my expectation is when I look at an operational feature flag, I should see almost an end runbook, right? It should be like, hey, here's the orchestration of how we are implementing logging. Here's all the variables you can use for it. And here's what we're looking for, why we're doing this, what to look out for. Your access level is engineering, right? And if your engineers are, utilizing, engineering operational feature flag to control aspects of, the system, why would you give this to an AE, right? So you need to separate like your permissions to operational, the engineering side and the business side, right? You shouldn't be cross them. Your risk level is high to medium. You almost want to think, if this is a critical system that I'm, like, hey, how many machines are up? And if it's too little, we could under provision. Do you really want your engineering interns in front end to touch it, right? Maybe not. So maybe you should build your risk level higher. Once again, your exit strategy should be, if the feature deprecates, we're no longer using it, get rid of it. So circuit breakers are actually, someone once told me, aren't circuit breakers the same as operational flags? Like, can't you say all operational flags? I mean, all circuit breakers are operational flags. And the answer is yes, right? They can. Your operational flag is a 1 or 0, then yes, it's a circuit breaker. So they're very similar. Your flag info should be governed by your engineering runbook. Your access level should be engineers, but your risk level is low, right? Because you know what happens is off. You know what happens is on. So there's no like complexities there. And your exit strategy, once again, is if your feature deprecates, go ahead and remove it. So let's go back to my Jira model, right? One of the things about Jira is you can build a Kanban board. And what's nice about a Kanban board in this example is I can see my flag info, right? Here, I can see we're rolling out 2 feature rollouts and 1 circuit breaker. So these things are coming in, right? I can see across my board how many feature flags are in development, how many are almost ready, how many is deployed, and how many experiments we're running, right? And I can see how many are ready to be removed, which is my technical debt. In terms of access, right? I brought up how we want to use a one-to-one relationship, right? So if you can access the Jira, you can access the feature flag, and this gives me that visibility. My risk, right? I can easily see the board. I can see how many are coming in, how many are being tested, how many deployed, right? And I can see, oh, 7 are about to come in. So that means that there's instances that, we have to be a little careful, right? Finally, my removal. As a quality leader, right, I want to make sure we don't have this technical debt. And I can see this right now. This system, I would say, actually is a little bit unhealthy, right? Almost 50% of the feature flags in my, in production right now are ready to be removed. They don't need to be here. That's a lot of technical debt. This is something that I would bubble up to my VP of engineering or to the CTO to say, hey, look, we need to take at least a day to pay down this debt, or this will come back and bite us. So let's test some end-to-end test strategy. I'm going to start with permissions. Permissions, there's a few things that you should be thinking about when you design your end-to-end test. One is that you want to check the provisioning is correct. There's nothing worse than, you turn the flag on and you tell your customers that they should be getting something and they don't get it, right? It's like a new feature. So you need to make sure that your automation is running that. Your automation should check all paths, right? You need to check both the, features that don't have it on and features that do have it on. You don't want, something to cross over by accident. You don't want it to have some weird interactions where, it doesn't work anymore in off, but it works in on, right? Those are both your customer base. And regression wise, one of the things that I always say is you want to have high sensitivity that you don't remove a customer's features. So those are the things that you really want to look at, not just the flow, but the big ticket items that you don't want to ever accidentally turn off because, you're bucketing into a permission. So if you look at, Cypress once again, pretty simple, right? We generally bucket our users into, our test runners into all the accounts, and then we do some actions. And this allows us to, bucket our tests as here's our free rollouts, here's our paid rollouts, here's our, tier 2 rollouts, right? And we can have confidence that these are being run. For operational, the strategy for this is a little interesting because generally speaking, yeah, you want to always validate your default, right? So if we're not putting any value into our configurations or our variables, does this feature flag still work, right? I think that's basic. That's your regression test case. Your strategies to validate operational values may vary. Does it make sense to write automation against the variable that you're about to introduce? Sometimes no, right? Because you don't know what's going to be changed. It's not always going to be the same. There's, it could be dynamic, right? We could decide to put something in there completely different that we didn't, originally plan for. So that's why default's important, because if we default back to the normal, we want a regression that hasn't crashed. But when you add a configuration value, most likely you're just going to manual test it, and that it works, that you're comfortable with it. So this kind of brings me back to point 3, right? It's hard to automate all the paths for operational, and sometimes you just need to manually test it. And there is no great strategy, and it may be too expensive. All right, circuit breaker. So circuit breaker, super important. I mean, obviously, regression tests if on and off still work. I laugh because it's pretty basic, but sometimes people forget to test the off stage. They just test the on stage, right? And then, when it turns off, sometimes it breaks. It's like, oh crap, we forgot that you can turn it off. Most of the circuit breaker feature flags I see are like this one here, this example. So here we wrap segment in a circuit breaker. So at any point we want to disable it, we can just turn it off, and third-party, integration is off. There isn't a lot of value to automate test these, right? You might want to manually test to see, it's working or not working. Maybe your logging is off or on, but really, why automate it, right? There's not a lot of value. So in this case, you just make sure it works, on and off, and you're good to go. So that covers governance and testing for, our different types of feature flags. And this kind of brings me to today's takeaways, right? And I have 6 for you. So 1, feature flags are powering modern deployment. They are super incredibly powerful. So many companies nowadays are using these to test, using these to make data-driven decisions, using these to experiment, to make sure that not just that the product is working right, but that the customers are really happy with it and they're getting a lot of value. And as quality leaders, we need to come to accept that this is, the better way to do things, right? Testing is not enough anymore to make sure you're successful. You need to get that data from the customer to make sure that the product is correct. Because at the end of the day, quality isn't just, is it working? Is our customers happy? Control the blast radius, right? Quality champions rejoice, right? Our mean time to remediate should be really good, right? If you are not getting your mean time to remediate value from feature flags, you should be really understanding why, right? The whole point of using feature flags and controlling that blast radius is another tool in your tool belt to control, the customer experience, to make things better. Thoughtful implementation, right? cool. If your engineering org has feature flags and you're using it, kudos. But as a quality leader, you need to make sure that your company has a strong process for releasing, managing, and removing your feature flags, or else the technical debt will punish you. I see so many stories where companies have feature flags and they start and they're like, this is amazing. They have 15 feature flags. Really cool. They see all the values of 1 and 2. But then after a few months, they start to have 100, 200, 300 feature flags. And suddenly, the VP of engineering looks back and says, oh my God, we have 350, we have 10 pages of feature flags. What's going on here, right? And that's really scary. Feature flag differentiation, right? Not all feature flags are alike. So why would you treat them so, right? Very, very few organizations I see differentiate their feature flags, and that's really dangerous. I see some companies that are really good about doing some of the things I mentioned in 1, 2, and 3, but then they treat their operational flags and their circuit breakers the exact same way they treat their rollouts, right? Anyone can access them, and that doesn't make sense. When you do automation testing, right, make sure it's deterministic, right? This is, like I said, it's like almost a no-duh thing to say, but I've seen companies where, hey, we hate feature flags because it causes our code to be flaky. Well, that's because your automation tests don't know what the feature flag's doing. And your automation test should have visibility, or it should be controlling the feature flags to make sure that you're testing what you think you're testing. Finally, to come full circle, the topic of this talk was quality leadership. And in this space of feature flagging, I've seen implementation strategies, I've seen implementation talks, but I haven't seen leadership talks on quality, right? What is your role of a QA lead, right? How should you be thinking of feature flags? What should you be pushing, and how should you be driving this? Rarely do I see talks about governance. Rarely do I see talks about smart testing, right? And as a quality leader, you need to drive this in your organization, or else feature flags will become a problem and they will cause quality issues. So that's my talk. Some resources, if you're interested in learning more about feature flags or trying them, here are some vendors. Obviously, I used to work at Optimizely, so they have a free tool. LaunchDarkly is probably the biggest company that everyone's heard of, and Split has their version too. If you would like to read more, Martin Fowler has a great talk about feature toggles, which kind of goes over some of the things that I mentioned. Getting started with feature flags, there's another talk here. And Unleash is an open source feature flag tool that I've seen a few friends, use and some companies start to look at. That being said, stay in touch. Here's my email and my LinkedIn. I would love to hear more from you if you have questions or thoughts or ideas. And at this point, I think I will open it up for Q&A.
Awesome, great presentation, Jeff. That was awesome. Thank you.
Thank you.
We do have some questions if you're ready.
Yeah, let's go.
Perfect. Jessica wants to know, are there some changes that would not be eligible for feature flags?
Are there some changes that would not be eligible for feature flags? Is there a way I can get an example of what changes that she's thinking about?
Let's come back to that one. I'll let her
Okay.
that. We got another one here. It says, at what point does your team remove the feature flag conditional branch? For example, the feature is now permanently part of the code base. Who is responsible for ensuring that the branch logic is removed?
It's a great question. So this has been a problem before because when it's not discussed in the implementation stage, it's hard to say, right? Your engineers have moved on to something else, or they leave and suddenly it's impossible to pull out. So the best strategy that I've seen is when you're designing your feature flag and you're designing your code, you need to have a contract with product to say, hey, what is my condition that I should remove this flag? And we don't build on top of it until it's removed. How long should it stay alive? And once those terms have passed, generally, like, rule of thumb is, alive for 30 days, no customer incidents, or alive for 30 days and X amount of visitors have used it and we've gotten so much percent conversions. At that point, that flag needs to be removed. And the expectation is each team has their own strategy, be it the on-call engineer, be be it that they put it into a feature flag removal day. It's like a hack day we used to use where we buy food and everyone sits in a room. This is before COVID, but different strategies. But you need to have that contract between product and engineering saying when we can do it and why we should do it.
Perfect. Next question. How do you control the FF on the Cypress automation?
So we use a few different strategies. For some of our feature flags, Cypress, when we log in using a test runner, we pass in a certain ID, and through Optimizely, we're able to use audience conditions to allow it to be bucketed inside or outside the feature flag. Also, we have some implementations in the SDK that allow us to know that the test runner is doing something to give it that experience. At Iterable, we also use Cypress, but we use query parameters. So a query parameter, say, blah, 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 index, blah, 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 on means that that page will be in the feature flag, that the experience will be turned on. So we have to create, our spec files to say spec on, spec off, and inside of spec on, it knows that the location of what page you're on should be bucketed on. So there is some mindful implementation there.
Great, perfect. What is the best way to create metrics around features and its success?
It's a good question. This kind of goes back to product, right? When product is using a feature flag to launch, right? Usually product has a pretty good idea of what their expectations are, right? Like X amount of customers, no bugs, if it's like a marketing thing, like how many conversions, how many touch points, how many uses, how many page views, right? So what generally I say is, keep it between 15 to 30 days. And within that 15 and 30 days, what is your expectation of usage, right? If it's usually like product might say like, oh, I want, 1 million customers to come in. And that's sometimes unreasonable, right? Because we don't want to wait for that. So I say within 30 days, how many customers do you expect? Could it also be, how many, if there's defect free, right? So what I look at usually is defect free, page views, something realistic that we can feel that it's good to go. And that's kind of what we bucketed at.
Perfect. Next question, what's more important, implementation or governance?
Great question. That's actually I would almost say a trick question, right? Because in engineering, right, your developers, they are focused on implementation and they're looking at the best strategy, right? And it's important. If you don't implement your feature flag correctly, it's not going to work and you're in trouble. But I think the gist of it is in order to aid our engineers and help them succeed and help our engineering organizations, our quality leaders, right? We need to be the one to do governance to allow them to succeed, right? Engineers don't want to think about policy. They don't want to think about, oh man, where do I have to write this or what do I do? They just want to be told, here is where you should put your data. Here's when you implement it, where you should be writing it, right? Is it a single pane of glass? Is it through Jira? But they want to be told what to do and then where to look when the time comes. So for this answer, I say both are important, right? But you can't have one without the other.
Okay, perfect. And Jessica does have a follow-up to that first question I asked you about the changes, and so give me a second here. Following up on my question, in my experience, organizations who introduce governance guidelines eventually want to make an exception. There may be a fundamental framework change or system upgrade that isn't easily switchable, or a change governed by a regulation, for example, GDPR, compliance, responsive design, where disabling isn't an option once live. Is it possible to design a QA model making use of feature flags for rapid deployment that sets ground rules for what changes are ineligible and therefore need more rigorous testing?
Wow, that's a mouthful.
Right.
I don't see why not, right? I mean, I think if you're thoughtfully implementing it and thoughtfully controlling it, it should make sense. I'm thinking of what you mentioned in terms of GDPR, right? Like if you're implementing it, yeah, I don't see why not, right? Like it is. I will say though, and I don't know if this answers it correctly, there always are going to be one-offs. And that's kind of the way engineering works, right? You have all these policies, you have all these like, best practices and standards that you play by, but there's always going to be something that comes out of right field that you have to drop and that you kind of have to jam in. I know for our company, we've jammed, an operational flag as a provisioning flag before, to allow certain users to get a certain feature, right? It's not the best strategy and it's not great, but sometimes, you have to use the right tool to do what you need. I think in this case, if you do something like that, the most important thing is to make sure you know the history and context of why you did it, be very clear on how to use it and why it's a one-off, and make sure people can find out, right? The worst thing I think what I see is if you do these one-offs or you make these changes or you kind of do things a little differently and no one knows why, and then people start to say, oh, okay, that's the standard, or that's, or no idea why to do it, and that's when things break down. So make sure you're very clear why the one-off is or why the change is, and how to kind of follow that.
Great, perfect answer. And I think that's all we have for questions. We do have some requests for your slides. So when we jump off here, just go ahead and send me your slides and I'll get them posted to the recording page and then people can access them.
Perfect, will do.
Awesome. Well, we appreciate that, Jeff. That was a great presentation.
Thank you. Thank you very much.
We hope to see you hopefully at an in-person conference soon.
Definitely. All right. Take care.
Perfect. So before we go today, just a couple reminders. Our next scheduled webinar will take place on February 24th, and Steve Hilton will be giving a presentation on the top 5 performance tests for the IoT. Visit SoftwareTestPro to sign up for this webinar and view all the upcoming webinars from STP. If you'd like to be considered for a webinar presentation or have an idea for a testing topic, visit SoftwareTestPro to submit your proposal. Thank you, Jeff, and everyone who joined today. Have a great day and stay safe.